Hi, future doctors. Welcome to the next class. In this class, we'll discuss some problems on work energy theorem and kinetic energy. See this problem. Kinetic energy of a body is increased by 300%. Percentage change in momentum will be. So we should come to know first kinetic energy and momentum relation. K is equal to P square by 2m. So from this, K is directly proportional to P square. So from this equation we can write K1 by K2 is equal to P1 square by P2 square. So our first video directly proportional, inversely proportional is on this equation only. But in place of a K came, in place of B P came. Now whenever they give percentage 300 greater than 5%, we should take initial values 100. Initial kinetic energy you can take 100. Final kinetic energy, how much? The increase 300 means 100 plus 300, 400. Initial momentum, all initial values you have to take 100. Final momentum we should calculate. So if you cancel 100 here, so now P2 square is equal to 100 into 400. So from this, P2 is going to be 10 into 20. So 10 into 20, you got 200. So P1 value, how much you have taken? 100. P2 value, how much you got? 200. Therefore, increase in percentage is 100%. Next, see, two bodies of masses M and 4M are moving with equal kinetic energies. Then, ratio of their linear momentum. Again, K is equal to P square by 2M. So two bodies having same kinetic energy. Therefore, K1 is equal to K2. P1 square by 2M1 equal to P2 square by 2M2. So we want ratio of linear momentum. Therefore, P1 square by P2 square is equal to M1 by M2. That is going to be P1 by P2 is equal to root M1 by M2. Root M by 4M. That is going to be 1 by 2. This is also first option 1 is to 2. Kinetic energy momentum ratio. Now see the next problem. A ball is thrown 100 grams from ground with a speed 20 meter per second. Come back to the ground with a speed 10 meter per second. Find the work done by the resistance. So this is work energy theorem. Why? Because initial velocity, final velocity they gave. So they have thrown with initial velocity comes with final velocity. Therefore, half mv square minus half mu square. So m by 2 into v square minus u square. What is the mass value they gave? 100 grams means 0.1 kg divided by 2 into what is final velocity? 10 square minus 20 square. So 0.1 by 2 into 100 minus 400. So minus 300 into 0.1 by 2. Minus 30 by 2 minus 15 joules. Here negative sign indicates work done by resistive force. Therefore answer is 15 joules. Correct. Now see the next question. Now in this question, see they gave graph. A particle of mass 0.5 kg is subjected to a force which varies with the distance. So the speed of the particle at x equal to 0 is 4 meter per second. At x equal to 0, 4 meter per second means this is initial velocity. Then the speed at x, 8 meters. They are asking what is the velocity at 8 meters. Initial velocity they gave 4 meter per second. So we will use work energy theorem once again. So half mv square minus half mu square. So what is the work done? Under force and displacement graph means area will give. This area you should calculate up to 8 meters only. Therefore, half base value 4, height value 10. So 4 into 10 plus here. What is the area under this means? 8 minus 4, 4, 4 into 10. This is work done of m. What is v means velocity at 8 square minus. What is u? Initial velocity they gave 4 square. What is the mass value? 0.5 kg. Therefore, 0.5 by 2 v square minus 16 should be equal to. What is the work done here? If it is cancelled 2 times, 2 2s are 4, 2 into 10, 20 plus 40. That is going to be 60. So v square minus 16 equal to 60 into 2 by 0.5. How much you will get? 60 into 2, 120 divided by 1 by 2, 240. So then v square is equal to 256. Then v is going to be 16 meter per second. This is going to be second option. So here they asked a velocity at 8, therefore we did like this. If they asked what is the velocity at 12 meters, then we have to find total area. So like this, we should do problem whenever they're asking. Next is the force experienced on particle F they give. Find the work done in moving object from 0 to 3a. This is the work done formula. Work done formula under integration. Integral f dx. Here x is changing from 0 to 3a. What is the f value they give means f naught into x by a minus 1 dx. You can expand this. So f naught into x by a dx minus f naught dx. What are the limits? 0 to 3a. 0 to 3a. So f naught by a is constant. Integral x dx. X square by 2 between the limits 0 to 3a. So integral dx x between the limits 0 to 3a. Now f naught by 2a. So x square, 2 I wrote here, x square means 3a whole square minus 0 square minus f naught into 3a minus 0. So if you calculate this, f naught by 2a, 9a square minus f naught into 3a. So I am writing here now, you can see. So what is common here? F naught, 1a will be cancelled here. 9 by 2 f naught a minus f naught into 3a. So you can take f naught a comma 9 by 2 minus 3. F naught a, so 9 minus 6 by 2, 3 by 2. So now answer is going to be first option. See, this is work done. All work done, energy, kinetic energy, work energy theorem, all are going to be same. See, this is how we have done integration by using this formula. All these we discussed in our basics, how to do integration. See the last problem. The distance x moved by a body of mass 0.5 kg and the action of force with time. It is changing with time distance. Then what is the work done by force in first 2 seconds? So this is distance they give. And in this time, what is the work done they are asking? Therefore, we have to apply work energy theorem of m v square minus half m u square. So half m into v square minus u square. Now mass they gave. How much? 0.5 by 2. We should calculate velocities. V square minus u square. I am doing velocities here. You can see what is the velocity equation for this integration. After doing integration dx by dt means 60 plus 4. So if you want to get initial velocity if you want to get, t value should be 0. T is 0 means 4 meter per second. Final velocity at t equal to 2 seconds. 6 into 2 plus 4. So that is going to be 16. Correct? 16 meter per second. Again coming here, if we substitute here, 0.5 by 2, 16 square minus 4 square. Correct? 0.5 by 2, 256 minus 16. 0.5 by 2, 256 minus 16 means 240. This is going to be cancelled in 12. 12 fives, so 12 into 5, 0.5 into 10. So 60 joules. This is the answer. Now see, this is the work energy theorem, how we apply it. I hope you people understood. Thank you.